So our final speaker of the day is Dr. Nico Peiren, and Dr. Peiren is senior researcher working within the Department of Animal Husbandry at the Institute for Agriculture and Fishery Research in Belgium. And I believe you are going to be talking to us, Nico, about reducing climate change impact through animal nutrition. So the floor is yours. Thank you very much. Please join me in welcoming Nico to the stage.
So there is already a lot talked about the possibilities, and now we're going to give a few practical examples how that we can reach the goals we have to reach. Because without farming, none of you would be here, and it are still the farmers that can have to produce the milk. A lot of these topics are already handled, because each time if we talk to a general public, we have to still aware them that methane is produced in the front, not in the rear. And also something is important, that without the microorganisms, the cow wouldn't work how she functions now. I won't go here into detail, but how is methane produced? It is the thing that we have to get rid here of the hydrogen. And this is done by the archaebacteria, and we want to steer it that there is produced as less as possible hydrogen by promoting propionic acids against acetic acid and butyric acid. So we can work on the herd management, we can work on genetics, but now I'm going to talk about the manipulation and the fermentation of the rumen with feed supplements and also with diets. Because these trials you will see will be all in vivo trials, so they work. All is based on a project that's recently ended that calls Smart Milking. This was a project that was by the Flemish government for a time period of 4 years. Yeah, I'm not talking too loud enough, so I will be a little bit closer to the mic. So we tested 4 different feed strategies. We looked at feed supplements, changing the diet composition, and also use byproduct or co-products. First, we did a screening for possibilities for some products that were potent. We did this in open circuit chambers. That's normally limited. We can't look at any performance, and we need also a large number of trials. Therefore, the second step was technical trials that we did in our own farm with measurements of methane and CO2 in our green feeds. And also at our dairy farm, we can have or monitor directly the dry matter intake. This is just not to put it in mind to you, but also just to show you a typical experiment. We always worked with control groups, then different treatment groups. First, an adaptation period, then an untreated period, then the treatment period, and then also a washout period to look at it. Some people ask me all the time, why didn't you work with crossovers? Here it is important that we want to get as close as much to the practice. So therefore we chose an 8-week period. Why that 8-week period? Also that we want to avoid that the cow physiologically, it changes too much, so that we have limited also that time. but long enough to see if we have a long-lasting effect. Also, something is necessary nowadays is to look at the carbon footprint of, in first instance, the milk production, but in second instance, it's also the importance of the feed used. Because it is not only the cow that counts, it's the whole system, like it is already discussed, that we need to follow. Also, if we look at the calculations for the carbon footprint, we want to incorporate it, the feed part already also, because nowadays, also for illustration, it's sometimes just looked at the farm level or the national level, and that it's something we can't look anymore because we can't have pollution swapping. We have to look at the whole system, not at one part of it. So as a few examples that are shown here, I want to have a journey that problems we have met, how problems we can resolve. First, we have an example from a linseed compound that we looked at pre-wilted grass silage, rich diet, and the maize silage. Then we go to the feed additive 3-oxypropanol. Then we looked also at an issue as maize silage rich diet versus grass silage versus diet. And also we look what happens if we incorporate brewer's grain and rapeseed meal as byproducts into a ration. This is just meant to tell you that it's also the ration plays a very important role into the whole effect. Sometimes with one ration we can have an effect, with another sometimes not. And this is here the case like it is seen. So here with a maize-rich diet we have an effect. With the grass-rich diet we don't have any effect. And this is not something that can be generalized for each type of product or for each type of additive we want to use. We have to have focus on multiple diets to can have a final conclusion if something works or not. So here you see that the direction is around 10%. First within our screening. And we see that the same effect is already reached if we put it also in practice. Also something that's important, don't look just at the mitigation potential of the methane. We also have to look at the nitrogen efficiency. So also in our research, the goal was we wouldn't accept any nitrogen efficiency loss. Also, the carbon footprint is important from the mitigation, their point, and also from the feed part. And then also, there is not enough subsidiation for the moment, so we have to look at the economic cost also. And this is not a simple thing looking at the economical cost because it's mostly a time point. Because when starting some experiments, something was very cheap. After 4 years, the price could completely be different. Communication is very important. So this is in Dutch because the project is written for our dairy farmers in Flanders. So from each experiment or trial we done, we made a fact sheet that also the farmer or the advisories could see what we really have done, what were the results, and also something that can be written with a little bit more, but still on one fact sheet that it could be comprehensive to everybody. And also with the dashboard that people also without that much knowledge could easily see was it positive or negative. So the second was the additive 3-knob. And there you see how it works. I won't go any detail. There we saw also very clear results that it worked by the screening. Then we went to the practical trial, and there we saw even better results. Therefore, you see, why did we see better results? We saw better results because by using the product, also by knowing the product, giving more information about the company, how it should work, we learned a lot. And there it is very important that it is a molecule that has to be in the feed most of the time. This means that it has to be dispersed to the animals during the whole feed period, or several days, several periods. And the first one met 80% reduction, that was only fed 4 times a day. Now with this, it was fed 8 times a day, so we see a clear difference. Also, what is important, if you want to put something on the market, you have to have a system that is useful in some countries, but also in other countries. Therefore, we don't test it only into the raw veg, but also in our Western Europe systems. It's also important that it can be put into the concentrate. And you see, putting the product in the concentrate for the first time, we have also the same results. Also, like you see, it's very short time work. It had to be from the moment we started the washout period, the effect disappeared. And here you see that we have better results in this practice trial. Mostly it is the opposite, that we have reductions here till 25%. So not as very promising, but for the moment we are still waiting that this becomes in the market. So some people are here of the company, so they promised, I will look at them now, that it would be normally 21 on the market. So yeah, we are still waiting, but we're hoping that it will be on the market. Also, it is important, if you introduce something, that we look at the carbon footprint, that the carbon footprint of the product is not that big, that it has an impact on the whole food chain, and that it's all the way that it is not useful anymore. So therefore, like you have just seen, the control, here we have the importance of the reduction is around 45 till 40% as the emissions from the cow itself, but to look at the importance of the diet, and certainly here if we look at the importance of the concentrates, therefore it is already said by previous speakers, if we can work at a basis with a grass-based system, that it has much less impact than if we look at the concentrate basis. And here, this is how much the additive contributes to the accumulated footprint of the emissions of the animal and the emissions of the feed. Now we go to the following, because it is said that maize, because of his starch content, causes a much less methane production than grass. This is partly true, but you can never have a ration if you want to equilibrate it, that we will see here that the differences are completely different also. So this is, I won't go any detail here because of the time. But if we look at the outputs, we don't see any difference between the reference cows and the treated cows. That's also the reason why we didn't do any practice trial, because at the screening trial we saw not any differences. Also, we made the carbon footprints of maize silage and grass silage apart, just maize silage and grass silage, and there we saw a big difference. But if we look what causes the difference, we see that mineral fertilizer, like Martin already said, plays a huge role, and also the number of times there have been on the field to harvest the maize silage or harvest the grass silage. It's also completely different. But if we look at now the diet composition, we see that for an equilibrated diet, that we see here that there is a little bit more soybean meal used. And there is also a little bit more concentrate used in percentage. It looks not that important, but if we look then at the grass silage diet and also at the maize silage diet, we see that the carbon footprint of that maize silage diet is a little bit higher, but not significantly. So the big difference that we had at the silage and maize and grass changes completely if you make a complete diet of it, because of that higher impact of the soybean meal and the concentrate importance with also a soybean meal in it. So we see evidence translated to the dashboards. We don't see any differences between a grass maize silage rich diet and a maize silage rich diet. Then the following, we looked at brewer's grain and rapeseed meal as biased products of beer making. So put in mind what will be my final message, that it will be useful for you to drink more beer. So the setup was completely the same. So control group, brewer's grain and rapeseed meal, and brewer's grain and soybean meal. This diet was formulated for the case that we want to formulate a diet with a small or a smaller carbon footprint than the traditional soybean meal rich diet. If we look at the control group compared to the brewer's grain and the rapeseed meal rich diet, we see there is an effect, and also after wasp period, but you see here the response is not that immediately that we see a clear effect. if we look at the brewer's grains and the soybean meal, you see that there is no effect because the starting point was higher, and if we look at it, there is no real differences in methane production expressed in grams a day. So we did the success of that brewer's grain-rich diet, rapeseed meal-rich diet. We saw reductions even if we look at the intensity of the methane, but we saw reductions till minus 30%. So you see, if we try to combine some packs, that the figure that Martin said from min 50%, that it's really a goal that we can reach. But there is a but. Like I already said, I should like that you drink more beer, because brewers' grains are not that available, and beer consumption is lowering still, so you have to do something about it if you want to keep a low footprint for the cows. So, and then the practice trial, we had still a reduction of minus 30%. But no effect on the methane level on the brewer's grains and soybean meal. Therefore, it was also important here, because that's why we made that diet, that we looked what the carbon footprint of it is, because this is an accumulating effect. If we look at the carbon footprint, we see a very clear difference between our control diets and our brewer's grain, rapeseed meal-rich diet. A little bit also in our soybean meal diet with brewer's grain, but not on the port. But how does it come? Because if we just should compare them without looking at the land use change, then we see no difference at all. But if we incorporate this, and it has to be incorporated, some people would not agree, but I want still to discuss with them, that makes that huge difference. Now, if we are accumulating these two effects, then we see a reduction of 33% into practical circumstances. So replacing soybean meal by combined brewer's grains and rapeseed meal lowers the total carbon footprint enormously. But here, like I already said, it's sometimes very difficult to advise the farmer, will it be economically effective for you or not, because these prices changes a lot. So that's also that we put in on our dashboard no real price indication, because the changes during the period that we did the trials were too huge. Then there is still the question from, we have found no effect with the brewer's grain in combination with the soybean meal. What would be the effect if we replace the brewer's grains, if we replace it all by rapeseed meal, and then we find some methane reduction, but very little. Also, we had a negative effect here on the nitrogen efficiency, but the carbon footprint lowered already also by 28%. So again, we put it into a tool because the farmer has to still make a choice that he can handle within the margins that he can play. Therefore, we made a tool available on our Smart Merken website. It's still in Dutch because it's to the Flemish farmers. That we can work with the window, what is important for him. Does he want to add roughage? Is it an important issue for him? Is concentrate an important issue for him? Are byproducts important? Does he want to use additives? Is the important between maize and grass, is it important to them? So within starting this, he will have a ranked figure with the products that are on the market at that time, that he can decide what is his best for him in his circumstances where he produces his milk in. So the final conclusions. Diet can have an impact on methane reducing capacity of feed components or an additive. So the feed supplementation method is clearly promising. A balanced, maize-rich diet does not lower mean enteric emissions compared to a balanced diet of grass silage. So brewer's grains and rapeseed meal has the potential to lower methane emissions. And also not methane emissions, but also a clear reduction of the carbon footprint of the combined feed and animal emissions. And still, the total carbon footprint has to be evaluated because there is a large effect with using some feed components, yes or no. So, replacing soybean meal by protein-rich products or feed lowers the total footprint of 1 kilogram of produced milk to a great extent. So if I talk about produced milk, it's the milk that is at the farm gate, not all the processing afterwards, because we focused on these two topics because this make the major bulk of all the emissions made expressed in carbon footprint during the whole process. Okay, thank you.
Questions?
Thank you very much for the lecture. Do you have any idea about the chemical background or the biochemical background of the 3-nitroxypropanol? How does this work, this additive? Or is there anything known about it?
Is there anything?
Known about it, how it works, what it does.
Yeah, so I'll just go a little bit back. So this is the way how it works. It blocks methyl coenzyme M reductase, and this is the way how it works. Oh. So it's also written or described in this publication.
And the brewer's yeast, is this a question of ethanol which is in the brewer's yeast? Because this can combine with, let's say, formaldehyde or something. Eh?
Well, with the brewer's grain on itself, we don't saw any significant reductions as the product itself. So we saw it just in combination with the rapeseed meal.
Okay, but this has nothing to do with small, small concentrations of ethanol, which could combine with formaldehyde or something and prevent methane production.
Then is the difference between why it doesn't work with why doesn't it work with soybean meal in the combination? Or if that should be the reason.
Thank you.
Thank you. Really nice presentation. I'm doing a PhD in animal science at University of Florida. And I'm working with methane mitigation strategies, and nitroxypropanol is always something very trendy. Some publications show that, and actually that's what you show, that there is no increase in efficiency or in productivity. Is there any idea or to do any follow-up experiment to use, I don't know, a feed ingredient or something to combine with nitroxypropanol to make use or to foster that capability that it has? Is there any idea from the company or any follow-up idea?
Yeah, we have entered project, but I just heard yesterday that it was not accepted. So, but that was the intention of it, yeah. So when the people of the company are next to you, so it's now to them.
Other questions? It's almost your final chance. Because we're going to start closing this session. No more questions? Thank you very much. So that brings us to the end of this day. More or less on time. We had to skip one coffee break, sorry for that, but we want to respect your schedules as well. We have received a lot of information, some quite technical, some more funky. We had a whole spectrum, and I think it's very complementary. We put different parts of the puzzle together, and with this information, maybe we can start answering this question. Is there a yes to cattle or no? I think we've seen some very convincing arguments today that we indeed can hardly imagine dealing with a sustainable future without livestock. I think that's probably the main message of today. It's absolutely required to organize our food systems and our ecosystems. But we have to keep the debate going, bring out the science, and debate the science, and keep on doing that, and communicate about it, I think. So I would like to thank everybody today present in this room for attending. Very much appreciated, especially people that came from very far. I would like to thank, of course, all the speakers. They all did a great job, and I'm very happy that I can close this day very successfully. And I wish you all a good trip home, and I hope to see you some other occasion. Thank you very much. Thank you.